Hi everyone and welcome back. Today we're going to take a look at Unit 1.4, Fractions and Decimals. This is page 94 in our textbook. Go ahead and put today's date up at the top, please. And let's take a look. So our two objectives for today. We're going to write fractions as terminating or repeating decimals. Write fractions as terminating or repeating decimals. We're also going to compare fractions and decimals. Compare fractions and decimals. All right, so we're going to write fractions as terminating or repeating decimals, and we're going to compare fractions and decimals. So the first thing we need to know is what is a terminating decimal and what is a repeating decimal. So a terminating decimal is one in which the repeating digit is 0, which means it actually just stops. Like if you get 5.4 or 0.875 or 0.24. Okay, those are terminating decimals. Repeating decimals will be like 0.6666666666 and so on. Okay, or 0.57575757 and so on. All right, those are repeating decimals. Terminating, end, repeating, go on forever. So we're going to be doing a lot of long division today. All right, please don't use the calculator because that's not going to help you. Or well, I guess it will help you, but you shouldn't be using it. So let's try not to do that. All right. Okay, let's take a look here at the first one. So we're going to write 7/8 as a decimal. So remember that 7/8 literally means 7 divided by 8. Okay? I'm going to do most of my work over here on the right-hand side, just because I need a little bit more room since we're doing long division. I'll try to write the best I can so you guys can see everything, and if not, I may have to go to a little bit smaller ink on here, but I think we'll be okay. All right, so we need to do 7/8. So 7 goes inside the house, and 8's going to go outside the house. Always give yourself a pretty good little top bar there to get you started, because you're probably going to need it. Okay, so we ask ourselves, does 8 go into 7? And of course we say no. So what we do is we bring in a decimal point and we slide it over. We change this to 70, and then we put our decimal point there. Okay? I'm sorry. Let's back up. Goes there. All right. All right, so will 8 go into 70? And the answer is yes. And then we say how many times? Well, it'll go in 8 times, which is 64. Okay, so 70 minus 64, that's going to give us 6. Okay, when we're out of numbers, we just bring in a 0. So 8 goes into 60, that would be 7 times. That would be 56. The difference of 4. Bring in another 0, and that one's going to give us 5. And that did come out exactly. So this is a terminating decimal, and the answer is 0.875. All right, go ahead and pause it, and let's try Got It questions 1A and 1B by yourselves, and come back to me as soon as you're ready. All right, let's take a look. So for this one, we have 4 divided by 5. So it'll be 4 on the inside, 5 on the outside. So 5 goes into 40. 8 times. So the answer is 0.8. That one was easy. We have 3/16, so we have 3 on the inside, 16 on the outside. Bring in your 0. Okay, 16 goes into 30 just one time, which is 16. And we have 14 left over. We need to bring in a 0. And let's see here. How many times does that go in? Looks like 8 times. Let's see. 8 times, so we have 16 times 8. And that's going to give us 128. So then we need to borrow, so that would be 3, 12 left over. Okay, we got 12 left over. Bring in a 0. Okay, so we need to see how many times 16 goes into 120. It should be 7 times, I believe. Which would make sense because 8 times was 128, so it should be 7. So we need to do 16 times 7, which is 112. That's going to give us 8 left over. We have 80, and that goes in 5 times. All right, so for this one, we're going to get 0.1875. All right, this is one you may want to have a separate sheet of notebook paper out to the side to show all this on. I didn't give you a whole lot of room on here, and sorry, I just couldn't squeeze it all in, but as you can see, I'm kind of writing over stuff, so if you need to check your multiplication, just do that out to the side on a separate sheet of paper, it's fine. Okay. Feel free to use a multiplication chart if you need to. Some of these you may have memorized. I don't usually have my 16s memorized too well. There's a few that I know, but not very many. So just kind of take your time and do what you need to do. All right, let's keep going. And this time we're going to do the same thing. We're changing them into decimals. And we're going to use a bar to show a repeating decimal. All right, so for this one we have 5/12. So we're going to do 5 divided by 12. So we have 5 on the inside. We're going to divide it by 12. It's not going to work, so we need to bring in a 0. Okay, so 12 will go into 54 times, which is 48. Give us 2 left over, bring in a 0. 12 goes into 20 just once, which is 12. That's going to be 8 left over. And we have 80, and it goes in 6 times for 72. And I have 8 again. All right. So when I keep getting the same thing over and over and over again, that means we're going to keep getting 6 over and over and over again. So what we do is we put our bar across just the number that repeats. All right. Only the 6 would keep repeating. So this is actually 0.416 repeating. All right. Then we call that bar notation. And the bar goes over just the number that repeats. So if 2 numbers repeat, it goes over both of them. But in this case, only 1 actually did, so that's all we have. All right, let's take a look at the next one. So we have -2/11ths. So we know it's going to be negative, obviously. So we need 2 inside the house and 11 outside the house. All right, so we need to do a decimal, bring it over. And 11 is going to go into 20 just once, which is 11. With 9 left over, bring in a 0. It's going to go in 8 times for 88. And I'm back to 2 again, which is going to be a 20. So what's going to happen on these is the 1 and the 8 are going to both repeat over and over and over again. All right, so it's going to be -0.18 repeating. All right, this one over here on letter A was 0.416 repeating. This is -0.18 repeating. So you kind of say the number it repeats as an actual number. Okay, don't say 0.18 repeating, because when you say it like that, it kind of makes it sound like just the 8 repeats. 18 is what's repeating. Okay. All right, go ahead and pause it and try some for 2A and 2B on your own, and come back to me just as soon as you're ready. All right, let's take a look. So we have negative 5/6. So for this one, we would do 5 divided by 6. And I hope that didn't mess me up by getting over that far, but that's okay. We'll figure it out here in a minute. Okay, so we have 0. Let's see, 6 goes into 50. That'd be 8 times, which is 48. And 2 left over, 20. So that would be 3 times. Yeah. 18. Okay, we get 2 again. Okay, so then that's it. All right, so for this one, it's going to be, actually, let's circle it up here so we don't get those confused over there. So it'll be negative 0.8, and then just the 3 is going to be repeating. All right, 2b, we have 7/9. So 7's on the inside, 9's on the outside. Okay, so 9 goes into 70. Let's see, 6, 7, 8. No, not 8. 6, 7. 7 times. So we have 63. And that would be 7 left over. Well, I'm back at 7, so it's going to keep being 70 over and over and over again. Okay, so we got 0.7 repeating. All right. This one is actually a special one. So in math, there are a few little shortcuts here or there. And one of them is that anything that is over 9 is actually repeating. So in this case, 7 over 9 makes repeating 7. So if I give you 8 over 9, it's going to be repeating 8, or 8 repeating, however you want to say it. Okay? If it's a 5, then it'll be 0.5 repeating. If it's a 4, it'll be 0.4 repeating. So anything over 9 well, anything but 0. Let me put it that way. Here, I'll put not 0. Okay, anything not 0, okay, over 9 will repeat. Okay, and as far as I know, it works with improper fractions too. I've never actually checked it, but yes, it does work. You just have to, you'll have to work it out, but you'll know it's going to be repeating something. It won't be that number. Okay, so like if I do like 11 over 9, since 9 will actually go into 11, it's going to go in one time, and then from there it'll start repeating and so on. Okay, so it won't be 11 repeating. That's not how it works, but that's kind of our general rule. Okay, let's take a look at example 3. According to the USDA, teenage boys should consume an average of 2,700 calories per day. About 360 calories should come from milk. To the nearest hundredth, what part of a teenage boy's total calories should come from milk? All right, so for this one, we have 360 calories out of 2,700. Okay, so one way that we can really save some time here is if you remember from last year when you simplified fractions or I just lost it. Not factor. What's my word? Oh, well, whatever. So we'll just keep it with simplified. Whenever you break them down, okay, one way that you can do it is if you see zeros like this, you can cross those off because you know they're going to cancel. All right, so what I'm actually left with then is 36 divided by 270. Okay, now you could have actually reduced by a little bit more there, but that's my word, reduce. There we go. I was trying to think of the word I was saying simplify, but reduce, yeah. You could reduce a little bit more, but we're just going to stick with this for now. All right, so we need to add in a decimal. Bring it over. Okay, so 270 goes into 360 just once. And of course, that's going to give us 270. Okay, and then from there we need to subtract. So we have 0, and then we got borrow. So that's what, 9? Yeah. Okay, so we got 9 there. So we get 90 left. Bring in a 0. Okay, looks like that's going to go in about 3 times. And I'm not sure what that is off the top of my head. $8.10. Let me do this. 8.10. Okay. So then when I subtract that, I'm going to be left with 90 again. So it's just going to keep repeating. So let's draw it this way. Okay, so from there it's going to keep repeating. So for this one, it would be 0.13 repeating. All right, now it says to the nearest hundredth. So we actually need to round this off. All right, so we aren't supposed to have repeating decimals. We need to actually have a real answer. So since another 3 would actually be behind here, remember our rounding rules that we usually say is 5 or more, let it soar, 4 or less, let it rest. Okay, so for this one, it would be 4 or less because there would be another 3 behind it. We're going to let it rest. So this would actually be 0.13. And it just says part. We'll just leave it like that. We won't label on this one. So this one is actually the answer. All right. So it is a little bit time consuming, and I know that, but it's just good to get that mental math really going. It just makes things go faster the more you practice it. All right, let's go ahead and go over to the next page. And let's try this one by ourselves. And as soon as you're ready, go ahead and come back to me. And let's take a look. In a recent Masters tournament, Zach Johnson's first shot landed on the fairway 45 out of 56 times. To the nearest thousandth, what part of the time did his shot land on the fairway? So we're going to have 45 divided by 56. Let me start that about here, I think. Alright, so it looks like the first time, let's see, if we round that off to about 60, should be about 8 times. So let's work that out over here. So 56 times 8 would be 48, and then be 44. Yeah, oh, we were really close. Okay, so that'd be 448. And it's going to give us 2 left over. Bring in a 0. Okay, that's not going to work at all. And then that's still 0, so that's 20. Okay, and then 200, that's only going to go in 3 times. 16, 168. And that's going to give us 32. Okay, and then we need to go one more time yet. And let's try 5. Yeah, that's as good as we're going to get. Yeah, because the other 50 is going to put over 330. Okay, good. All right, so that gave us 5. And then that's going to be 280. And let's see. Going to give us 40 left over. Kind of writing in the one down there, sorry. All right. Okay, so for this one, we're actually going to stop there because we need to round to nearest thousandth. Okay, remember that the 8 is in the 10th place, the 0 is in the 100th place, the 3 is in the thousandth place, and then the 5 is actually in the 10,000th place. So since we need to round to nearest thousandth, we needed to go to 4 decimal places. So for this one, we need to round off. So it'll be approximately, which is a squiggly equal sign, and it'll be 0.80, and then we got to round up because it's 5. 5 or more, let it soar, so it'll be 0.804. So about 80%. Okay? All right, let's try the next one. All right, we're going to replace the circle with less than, greater than, or equals to make a true sentence. Okay, so for this one, we have 1/4. Okay, we know that a fourth of a dollar, right, 0.25. And we're going to compare that to 0.2. All right, so which one is actually bigger, a quarter, or in this case, we'd actually have 20 cents. Okay, so if you add in the 0 back there, it'd actually be 20 cents. So we know that the quarter is bigger, so that would be greater than. All right, let's come over here. So it's -5/8 compared to -6/9. Now we know from our previous one that -6/9 actually means -0.6 repeating, okay, because anything over 9 repeats, and we need to figure out what 5/8 is, and let's work that out over here. So let's do 5 inside the house, 8 on the outside, and that's going to be 6. It'll be 48, 2, 0, 1, no, twice. 16, 4, 5. So we get 0.625. Okay, it's negative. So that compared to negative 0.6. Well, this one would actually be 6, 6, and so on, right? Okay, so for this one, what we'd actually have here is it's actually not what you think. Remember, the one that's larger is going to be closer to 0. So in this case, the 0.625 is actually the larger one. So in this one, it's going to be greater than. Okay? All right, let's go ahead and try 4a and 4b all by ourselves. And come back to me just as soon as you're ready. And let's take a look. So we have 7/8 and 0.87. So we just literally need 7/8 into a decimal. And we actually had that one at the beginning. So I just used it. So it'd be 0.875 compared to 0.87. And to make it match, there'd be a 0 here actually. Okay, so for this one, we should have greater than. And then over here we have -7/15, so that would be 7 on the inside, 15 on the outside. Oops, let's try that again. 15, there we go. All right, so 15 is going to go in there 3 times, or 4 times. 4 times for 60, yeah. Let's see, so 4 times, which makes 60. 10 left over, bring that in, so that would be 6 times for 90. Yeah, that's going to be as far as we get, 6 times. And then we get 10 again, so it's just repeating. Okay, so we get negative 0.46 repeating. Over, and we have -5/12. Let's see, that's going to go in 4 times for 48. 2 left over, that's going to be 20, so that's going to go in 1 time, so that's going to give us 12, so there'll be 8 left over. And actually we can stop there because we already know it's 0.41, so we can actually stop there. So it's going to be -0.41 something something, and from there we know it's going to be less than. Okay, so on this one there was a shortcut just because I knew as soon as I got to the 1 I could stop because all I needed to compare to was the 6. Okay, now if I got a 6 then I need to keep going, but I didn't have to. All right, so you can certainly do those shortcuts. Just get it far enough to where you know what exactly you need for those. All right, let's take a look at example 5. We're almost done. 30 out of 36 7th graders and 34 out of 40 8th graders participated in a marathon for charity. Which class had a greater fraction participating in the marathon? So for this one, we have 30 out of 36. And then we have that compared to 34 out of 40. All right. Now, I'm actually going to take a little bit different approach here just so we can kind of get some smaller numbers here. Let's practice reducing and simplifying a little bit. So we think to ourselves, what goes into 30 and 36 that we can reduce by? And that would be 6. So this would actually be the same as 5 over 6. And then over here, what goes into 34 and 40? And that would be 2. So that would be 17 over 20. All right, oops, this should be over. There, 17 over 20. All right, so that makes it a whole lot easier to work with. So 5/6, so let's do 5 divided by 6. And I think we did that one earlier too, if I remember right. Look back at my book real quick. 5/6. Yes, we did. It was 0.83 repeating. Okay, so this is 0.83 repeating. So we're going to compare that to 17/20ths. So we're going to do 17, actually I'm going to show you another shortcut here. So a decimal is usually out of 100, right? So all I got to do is multiply by 5. So if I do 17 by 5 over 20 times 5, that's going to give it to me out of 100, and then that'll be my number. So we just need to take 17 times 5. That's a little shortcut you can take. So that's 85. So it'll be 0.85. And that would be greater than. No, less than. Yeah, less than. So which class had the greater fraction participating? It would be the 8th grade. All right. And then one more to go. Go ahead and pause it whenever you're ready to try this one on your own, and come back to me as soon as you're ready. And let's take a look. So it says, over the weekend, 16 out of 28 of the 8th grade girls and 19 out of 30 of the 8th grade boys went to see a new comedy movie. Did a greater fraction of girls or boys see the movie? So we have 16 over 28 compared to 19 over 30. Okay, I'm going to use the same little shortcut that I did last time. I don't want to really figure out what 16 over 28 is going to be divided out, because I can make the number smaller and easier to work with. So I'm going to look for the common factors, so I can reduce each of those by 4. So when I do that, that's going to turn it into 4 over 7 compared to 19 over 30. Okay, so whenever I do that, it just makes it a little bit easier. Okay, so 4 7. So we know it's going to be just over half, right? Because 3.5 would be halfway to 7. So we know it's going to be just over 0.5. So let's figure out what that is. So we're going to have 4 divided by 7. So that's going to be 0 there. Bring that over. And that's going to go in 3, 4, 5 times. 35. 5 left over, and then 7 times, yeah, for 9. 1. And I think we'll just stop there. It's going to keep going, but I think we'll be okay if we just hold it right there. Okay, let's do 19 and 30. So 19 on the inside, 30. So it's going to go in 5, 6 times, yeah, for 180. Yeah, actually, we can already stop there. Okay, we can already stop there because we know we have a 6 here and we have a 5 here. So since the second number was the boys, we can actually stop because we can clearly see that they had the greater number. So the boys were the ones who had, let's actually make that into a B. Almost looks like 13, sorry. All right, so we got boys for that one. Okay. All right, that's it for that. This one here. I know this one was a little bit longer and it's a little bit more time consuming. Just take your time, watch your math close, and you'll do great. So thanks so much for watching, and I'll see you next time.